So now we start with the proper formulas for this trigonometric. So first is for the compound angles. What is a compound angle? Sum of two or more angles is called a compound angle. So let's say if you have sine of alpha plus beta, you can write it as sine alpha cos beta plus cos alpha sine beta. Sine alpha minus beta, again the same thing, the only thing that changes here is the sign. So if you have a plus and you are finding out the sine of these two angles, you are going to have a plus sign in your answer as well. So if there is a minus sign, you would have a minus in your answer as well. However, for cos works completely opposite to what sine is going to work. So for sine, we were having sine alpha cos beta. However, for cos alpha plus beta, first of all, if we have a plus, we are going to have a minus in between our two terms, and we would have cos alpha cos beta minus sine alpha sine beta. When we talk about cos alpha minus beta, we would have cos alpha cos beta plus sine alpha sine beta. So again, the formulas start from here, and now you have to start remembering all these formulas so that you can solve your questions related to trigonometry. Now let's say if we have the sum of two angles of, let's say, tan and cot. For tan, if let's say you do not remember the formulas for tan, you can simply write it as sine alpha plus beta upon cos alpha plus beta. Write down their formulas as you have studied for sine and cos. Then try to take things common from the numerator as well as denominator so that you can try to form it in the tan form only. If not, you can directly remember the formula, which is tan alpha plus tan beta upon 1 minus tan alpha tan beta. When we have a minus sign in between, the only thing that changes is the sign in our answer. So it becomes tan alpha minus tan beta upon 1 plus tan alpha tan beta. For cot, it is not necessary for you to remember the formulas for cot. You can simply write it down as 1 upon tan of alpha plus beta. So once you write down the formula for 1 upon tan of alpha plus beta, so it would become, in the denominator you would have tan alpha plus tan beta, and in the numerator you would have 1 minus tan alpha tan beta. Then you can convert your tan alpha as 1 by cot alpha, tan beta as 1 by cot beta, and then take the LCM and then find out your answer. It would come out to be in this format only. Now again, some standard values that we've already studied were 0, 30 degrees, 45, 60 and 90 degrees. Now there are a few more that you need to remember about 15 and 75. So sine 15 is equals to root 3 minus 1 upon 2 root 2, which is equals to cos 75. Now why is this so? So I hope you all remember sine of 90 minus theta is equals to cos theta. So from here we get sine 15 is equals to cos 75. So that is why, and sine and cos are basically co-ratios of each other. So that is why we get this answer. And cos 15 is equals to sine 75. That would be root 3 plus 1 upon 2 root 2. For tan 15, we have the value as 2 minus root 3, which is equals to cos 75. Cot 15, we have 2 plus root 3, which is equals to tan 75. Now let's say if you forget the values of sine 15 or cos 15. So how are you going to find it out in your examination? So let's say if I have sine 15 degrees. So can I write it down as sine of 45 minus 30? So now I am basically finding out the difference of two different angles. So here we studied the formula. Sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. So I can write it down in that format. So this would become sine alpha cos beta minus sine beta cos alpha. So now if I try to find out the values, this would become 1 by root 2, cos 30 is root 3 by 2, minus sine 30 is 1 by 2, and cos 45 is 1 by root 2. So from here what do we get? 2 root 2 would become our LCM, and we would have root 3 minus 1. So this is how you generally find out the value of sine 15, cos 15, tan 15, cot 15. It is recommended that you remember so that you can directly put the values in the question and solve your answer. Now let's look at this question. If tan 15 plus 1 by tan 75 plus 1 by tan 105 plus tan 195 is equals to 2a. So basically we need to find out the value of a here. So first what we'll do is, first we'll convert each and every term in the numerator form so that we have each and every terms added as simply numerators. We do not have anything in their denominators. Then we'll try to convert all of them in the same trigonometric function, either tan, and here you can see we have tan, so its co-ratio is going to be there, which is going to be cot. So either tan or cot, and then we'll see what we can do with this question. So first let's convert. So this would become tan 15 plus this would become cot 75 plus cot 105 plus tan 195. Now what I'll do is I'll start writing them in their values. So for example, I know the value of tan 15, right? Apart from that, I do not know what cot 75 would be. So what I'll do is I'll start writing them as 90 minus theta or 180 plus theta or 180 minus theta or in those formats, so that I can convert them into their lowest degree formulas, and then I can directly write down their values. So this would remain as it is, tan 15 cot 75. Now cot 75 can be written as cot of 90 minus 15 plus cot 105. Cot 105 can be written as cot 90 plus 115. Tan 95, tan 195 can be written as 180 plus 15. So now if I try to convert them, all these angles in 15 format, cot of 90 minus theta is simply tan theta, and since it is lying in the first quadrant, in my first quadrant all my trigonometric functions are positive, so this would become simply tan 15. Now here cot of 90 plus 15, so of course 90 plus 15, it is still going to be tan 15, but we know that cot 105 lies in the second quadrant, and in my second quadrant, apart from sine, each and everything used to be negative, so my tan and cot would also be negative, so this would become minus tan 15. And tan 180 plus 15, so 180 plus 15, that means I have it in my third quadrant. In my third quadrant, as per cast rule, my tan used to be positive, so if my tan is positive, this can be written as plus tan 15. So minus tan 15 plus tan 15 gets cancelled out, and we have 2 times of tan 15 left, and this value they've told us that this is equals to 2a, so 2 and 2 gets cancelled out, so we have a as tan 15. And what is the value of tan 15? It is 2 minus root 3, which we just saw here. Tan 15 is 2 minus root 3. So we've gotten our a. Now simply we'll find out the value what has been asked to us in the question. We have to find out a plus 1 by a. So a, this would become 2 minus root 3 plus, here I would have 1 upon 2 minus root 3. So now let me try to rationalize this portion here. So this would become 2 plus root 3, and on top also I'll multiply it by 2 plus root 3. So here I would have 2 minus root 3 plus, in the denominator I would have 4 minus 3, which would make it 1, and numerator I would have 2 plus root 3 simply. Now from here you can see plus root 3 minus root 3 would cancel out themselves, and here I would have 4. This is my answer. So this is how you are generally supposed to solve questions. Try to convert first of all each and every term in such angles whose value you know, either by doing 180 plus theta, 180 minus theta, 90 plus theta or 90 minus theta, and then put their values and then solve your answer. Now double angle formulas. Now double angle formulas, again, these are the most basic formulas which you must remember. Now the way of proving them is, I know the formula of sine alpha plus beta, right? So sine alpha plus beta used to be sine alpha cos beta plus cos alpha sine beta. So for double angle formula, what I'll do is I'll write down my alpha is equals to beta. So simply I would have sine of, what I'll say is both these I'll represent as theta. So this would become sine of 2 theta. Here I would have sine theta cos theta plus cos theta sine theta. So it would become 2 times of sine theta cos theta. So this is how generally the proof of double angle formulas is done. Simply you can remember your formulas, the trigonometric identity that we studied, and based on that you can find out your double angle formulas as well. So for cos 2 theta as well, it is going to be cos square theta minus sine square theta. Now this can be written as 2 cos square theta minus 1, because I can replace my sine square theta as 1 minus cos square theta, because we know that sine square theta plus cos square theta is 1. So based on that I am writing this formula. Now similarly for cos square theta also I can do the same thing. So it would become 1 minus 2 sine square theta. And tan 2 theta. Tan 2 theta can be written as sine 2 theta by cos 2 theta. If I was to represent only in tan format, it would become 2 tan theta upon 1 minus tan square theta. Now this tan 2 theta, this can be again written from this formula only, tan alpha plus beta. Now what here I'll do is, I'll take alpha as theta, I'll take beta as well as theta. So it would become 2 tan theta upon 1 minus tan theta square. So this is how we get our double angle formula. Now if this double angle formula I convert it into the other way around, so it would become my half angle formula. So simply sine square theta, from here I can take my sine square theta, it would become 1 minus cos 2 theta by 2. Since I have cos 2 theta as 1 minus 2 sine square theta, so from here if I find out the value of sine theta, sine square theta, it would become 1 minus cos 2 theta upon 2, right? So this is what has been written. And since my sine square theta is this, so if I remove the square root from, if I remove the square from here, so this would become sine theta is equals to root under plus minus of cos 1 minus cos 2 theta upon 2. Now instead of theta, let me replace theta by 2. So if I put theta by 2 in all the places, I would get sine theta by 2 plus minus root under 1 minus cos theta by 2. Similarly for cos square theta also we'll use the same formulas. And for tan theta by 2 as well. Since we know tan 2 theta is this, so from here we'll find out the value of tan theta and then we'll replace it here. Now for tan theta, remembering this formula is very important for you because it has been written in cos theta format, right? So that means I can say that my tan theta would be equal to plus minus root under 1 minus cos theta upon 1 plus cos theta, or my tan square theta. This formula is the most important one. Tan square theta can be written as 1 minus cos theta upon 1 plus cos theta. So remember this thing. Let's look at this question, which again uses our concepts of half angle, double angle formulas. So 5 tan square theta x minus cos square x is equals to 2 cos 2x plus 9. So here first and foremost thing, the most important thing that we can see from here is that we have cos x, we have tan x, and they are in their half angle formulas, so they can be converted into their cos 2x format. So once I have all these trigonometric functions in my equation as having the same theta, which is my 2x, then I can solve it very easily. So I'll write it down as tan square x. As we studied here, tan square x can be written as 1 minus cos 2x upon 1 plus cos 2x minus cos square x. Now cos square theta can be written as 1 plus cos theta by 2. So this would become 1 plus cos 2x by 2, and I'll let this cos 2x be as it is. So now what I'll do is, I can see that there is a lot of cos 2x in my formula. So I'll simply write down cos 2x as t. If I represent it by t, then it would become very easy for me to solve this entire equation. So it would become 5 of 1 minus t upon 1 plus t minus 1 plus t upon 2. This is equals to 2t plus 9. So I'll take the LCM here. This would become 2 times of t plus 1. And here I'd have 2 minus 2t minus, here I would have 1 plus t whole square. This is still multiplied by 5 and this is equals to 2t plus 9. So from here, what are we going to get? I'm taking this equation here. So this would become 5 by 2 times of t plus 1. And inside what do we have? This would become 2 minus 2t minus 1 minus t square minus 2t. And this entire thing is equals to 2t plus 9. So from here you can see that we can take, this would still be 5 by 2 times of t plus 1, and inside we are going to have minus t square minus 4t plus 1. This is equals to 2t plus 9. So now if I look at this equation, is there any type of factors that I can find it out for this? So if I try to solve this quadratic equation, it would become t is equals to minus b, which is my 4, plus minus root under b square minus 4ac upon 2a. So this would become 4. This would have root 20 in it. So there are no general, basically direct rational factors to it. So simply what we'll do is we'll cross multiply this t plus 1 as well. So we would have minus 5t square minus 5 4s are 20t plus 5. This is equals to 2 2s are 4, and if I multiply, this is basically written as 2t plus 1, sorry 2t plus 2. Now if I cross multiply it, I would have 4t square here plus 4t plus 18t plus 18. So from here now, if I take all these values to one side, I would have 9t square. Here I would have 4t plus 18t, which would make it 22t plus 20t, would give us plus 42t. And here I would have plus 13. This is equals to 0. So now I have a quadratic equation which is in this format: 9t square plus 42t plus 13 is equals to 0. Now I have my quadratic equation in this format. So from here, what I can do is I can simply find out the factors. This can be easily factorized. So this would become 3t plus 1. One of the factors would be 3t plus 1, and the other one would be 3t plus 13. This would be our factor. So what do we get? The values of t, minus 1 by 3, and the other value of t would be minus 13 by 3. So basically I'm getting my cos 2x as minus 1 by 3 or cos 2x as minus 13 by 3. So if you look at minus 13 by 3, basically it is 4 point something, right? And we know cos value ranges only from minus 1 to 1. It cannot go up till minus 4. So this value gets rejected. So my cos 2x is this. Now what was asked to us in the question? We had to find out the value of cos 4x. So cos 4x, can it be written as 2 times of cos 2x whole square minus 1? So this would become 2 times of minus 1 by 3 whole square minus 1. So from here we get 2 by 9. 2 by 9 minus 1 would give us minus 7 by 9. So this becomes our answer. So this is how you could have solved this question. Now let's say the other way of solving this question would have been, you could have written your cos 2x in your cos format and your tan square x as sine square x by cos square x, and then you could have replaced your sine square x by 1 minus cos square x. Then you could have assumed your cos square x to be, let's say, t, and then solved the equation. Then you would have again received 2 factors. Based on those 2 factors, you could have solved your question. So generally trigonometric functions are to be solved in such a manner that you first bring all the trigonometric functions into the same format and then try to solve your question. Now talking about triple angle formulas, we studied about double angle. Now triple angle formulas. Now sine 3x can be written as 3 sine x minus 4 sine cube x. Cos 3x can be written as 4 cos cube x minus 3 cos x. Tan 3x can be written as sine 3x by cos 3x, and then finding out the values. Similarly for cot as well. So again, formulas for you to remember. Let's look at this question now. The value of 36, 4 cos square 9 minus 1, and we have a lot of values. So first what I'll do is I'll try to assume this to be 4 cos square theta minus 1. Now I'll try to simplify this in some format so that I can find out my value. If this becomes simplified, then it would become very easy for me to multiply it, right? So that is why I'm assuming my angle to be theta for a moment, just for me to solve it. What I can do is, if I try to remember my triple angle formulas, I have 4 next to my sine cube x and 4 next to my cos cube x. However, if I try to transform this into cos, it would become quite difficult for me. So I'll transform this into my sine. So I'll write it as 4 of 1 minus sine square x minus 1. So this would become 4 minus 4 sine square x theta, sorry, minus 1. So this becomes 3 minus 4 sine square theta. So now you can see that this is somewhat close to my triple angle formula, which used to be 3 sine x minus 4 sine cube x. So if I multiply this by sine theta and divide by sine theta, wouldn't the top transform into my triple angle formula? It would become 3 sine theta minus 4 sine cube theta upon sine theta. So this is basically my triple angle formula now. So this would become sine 3 theta by sine theta. Now you can see that I have tried and simplified this entire equation. Now I can replace it in this equation. So I would get 36. Here I would have sine of 27 by sine 9 into sine of 81 by sine 27. Here I would have sine of 243 by sine 81, and here I would have sine of 729 upon sine of 243. Now you can see it has been simplified way higher, so this would become, all these values would simply just cancel out amongst each other. We would have 36 times of sine 729 by sine 9. Now how can I write down my sine of 729? 729 can be written as sine of 720 plus 9, and 720 is basically my multiple of 180 degrees, so I would have sine in my first quadrant only. So since 720 is a multiple of 2 pi, which is my 360 degrees, so I've taken one round, I've gone 360 degrees, then I've gone one more round, I've gone 720 degrees now I've taken 9 degrees, so it is going to be in my first quadrant only, so it would be positive, and it can be written as 36 times of simply sine 9 by sine 9. This gets cancelled out and we are left with 36, and this becomes our answer. So this is how generally you solve the question. Let's say sometimes in questions they have given you a long multiplication values or long addition or subtraction values. What you must do is try to find out patterns such that you can simplify it. For example, whenever you have multiplication, try to bring it in numerator by denominator format, so that all the denominators and numerators can get cancelled out and your value would become quite simpler. Let's say if you have plus in a lot of series, try to convert it in such a format so that you have a positive term minus some other term, so positive term and a negative term, and then you would have this for a series. All the negative terms would be cancelled out, and then again you would be left with some simple values. So try to convert your equations in such format, then you would be able to solve your questions. Let's look at a few more formulas. Let's say if you have sine A into sine of 60 minus A, sine of 60 plus A, then you can directly write down the answer as 1 by 4 sine 3A. For cos as well, it becomes 1 by 4 cos 3A. For tan, it becomes tan 3A. So do not confuse yourselves, because whenever I write down tan 3A, it is going to be sine 3A by cos 3A, right? So if I multiply a 1 by 4 both in the numerator as well as denominator, can I write this entire equation in this format? And then in the denominator I would have this. So basically that is how it would transform into. So keep this thing in mind. Now one more important numerical degree that you need to remember. So apart from 0, 30, 45, 60, 90, and then we studied about 15 and 75, you need to remember 18, 72, 36 and 54 as well. So again, you can use your different compound angle formulas, double angle formulas to find out these values. So simply we are going to remember it. Sine 18 is root 5 minus 1 by 4 is equals to cos 72. Sine 36, there is just a little printing mistake here. This would be root under entire for the entire thing. So keep this thing in mind. Only for root under 10. So this cos 54, which is equals to sine 36, this value is basically equals to 10 minus 2 root 5 divided by 4. So keep this thing in mind, and here we have root under 10 2 root 5 upon 4. So these are again few values that you need to remember. Now coming to our transformation formula, all these formulas, what we call them as are transformation formulas. Now these are also known as our factorization formula as well, because what we are doing is we had two trigonometric terms added or subtracted with each other. Now we are converting it into a product format. So basically we are trying to find out its factors. So this is how their factors are written. So sine C plus sine D can be written as 2 sine C plus D by 2 cos C minus D by 2. Sine C minus sine D can be written as 2 cos C plus D by 2 sine C minus D by 2. And for cos, I hope you all know cos works completely opposite or differently from sine. So we would have cos C plus cos D as 2 cos C plus D by 2 cos C minus D by 2. Cos C minus cos D would become minus 2 sine C plus D by 2 sine C minus D by 2. Again, formulas for you to remember. Now converting it into the other way format. Now there we were studying about factorization formula. Now this is basically a defactorization formula. So this is how they can be written. Sine 2 sine AB can be written as sine of A plus B plus sine A minus B. So again, formulas for each cos and sine, you can remember it. Again, more or less the factors and defactors are kind of same. The trigonometric functions are same. The only thing is you need to remember the value of angles. So keep that in mind. Let's look at this question now. The value of sine 10, sine 30, sine 50, sine 70 is. So just by the look of it, I hope you must have guessed it. We can see sine 10 here, we can see sine 50 here, we can see sine 70 here. So if I take sine 30 outside, so this can be written as sine 10 into sine of 60 minus 10 into sine of 60 plus 10. And this was the formula that we just studied, sine A into sine of 60 minus A into sine of 60 plus A. So sine 30 is basically 1 by 2. We can write it down. So this value would simply become 1 by 4 times of sine 3A. So 3 into 10. So 1 by 2 into 1 by 4 into sine 30 is again 1 by 2. So we would have our answer as 1 by 16. So this becomes our answer. So this is how you must identify what type of formula is to be used in specific questions and then solve your answer. Now a few more formulas for you to remember. Now this is for us to convert our sine or cos into tan format or a tan into sine format. So sine 2 theta can be written as 2 tan theta upon 1 plus tan square theta. Cos 2 theta can be written as 1 minus tan square theta upon 1 plus tan square theta. Now remember one thing, for tan 2 theta, what was the formula that we studied? It used to be 2 tan theta upon 1 minus tan square theta. So do not confuse yourselves with tan 2 theta and sine 2 theta. Again, a formula for you to remember, sine A plus B into sine A minus B. What I'll do is I'll simply open this up in our compound angle formulas that we had studied, and we would get sine square A minus sine square B. For cos also we would get cos square A minus sine square B, or this can be written as cos square B minus sine square A. Tan pi by 4 plus theta. Now here you can apply a compound angle formula. So this would become basically tan of pi by 4 plus tan theta upon 1 minus tan theta tan pi by 4. And we know the value of tan pi by 4. Tan pi by 4 is 45 degrees. So it is equals to 1. So this basically transforms into this formula. Now if I take tan theta as sine theta by cos theta, it would transform into this formula. And for minus as well, we get this one. So keep these formulas in mind because these are important for your conversion of sine to tan or cos to tan. So this can come handy while solving questions as well.